Welcome. Class question 37. Again concept based question. See, last time we considered uniformly varying double overhanging beam, varying load, 0 at one end and maximum other. Now represented by a UVL in the form of trapezium. Not difficult. And question I will give you, a beam of length 8 plus 2, 10, 12.5. A beam of length 12.5 meter, full length I am giving, see, 12.5 meter, has simple supports at 2.5 meter from left end and at 2 meter from left end and at 2.5 meter from right end. Or simply support span of 8 meter, left overhang of 2 meter, right overhang of 2.5 meter. It is loaded by uniformly varying load with intensity of 20 kN per meter at the left extreme end, which linearly increases to 50 kN per meter at the right extreme end, or maximum of 50 kN per meter at the right end linearly reduces to minimum of 20 kN per meter at left end. Find reactions. Okay, as usual, let VA, VB all I told. Very important class I will tell you. This time, see, if you take moment, you should write here. See, I will tell in the class. If you take moment about, when you take moment about A, see, suppose you take moment about A here, and this side load will produce clockwise moment, this side load will produce anti-clockwise moment. So therefore, suppose you split here, you get trapezium this side and also trapezium this side. Oh, problem. Or then again, if you are afraid of trapezium, what you have to do? You are divided into rectangle, triangle, rectangle, triangle. Too much of complication. So I told you, for UVL, separating either side is not ideal. UDL, okay. So what you do is, you make a note, directly trapezium, why are you afraid of trapezium? But if you are afraid of trapezium, I will tell you, so take the full load into account. Therefore, make a note here. We will solve the question directly. See, this point I will take C, this I will take D, considering entire load from C to D. Entire load from C to D. Full load. Okay, then, see there, A, B, this reaction VA, this reaction VB. Take moment about A, minus VB into 8 as usual. Then, moment of this entire UVL about A you want. See, moment point is here. So what you do is, if you consider the entire UVL, you know it. Total load is area of the trapezium, sum of the two parallel sides, 20 plus 50, divided by 2 into distance between the two parallel sides, 12.5. This will give you total load. And line of action of that total load will be from here, this side plus twice of that side, divided by this side plus that side, into whatever is distance between the two parallel sides, divided by 3. Okay, I wrote here. Pencil, you write it here. Write using pencil. Or if I want distance from here, later when I take moment about B, it is this side plus twice of this side, divided by this side plus this side, see, into total distance by 3. So this distance will be 20 plus twice of 50, divided by 20 plus 50, into 12.5 by 3 is this distance. Or from here, 50 plus twice of 20 divided by 50 plus 20 into 12.5 by 3 is this distance. So if you do that way, you get very fast answer. So here now see, take moment about A, minus VB into 8, you take the entire load, it will act somewhere here. Then, so total load, I already explained for you, into, but remember, this will give distance from here. We want moment about A. Since you want moment about A, we want what? See, we want this distance. So that distance equal to whatever is this distance, subtract 2 meter equal to 0, you get the value of VB. Sigma V0, you get the value of VA. Sigma V0, what you do? VA plus VB, total load, 20 plus 50 divided by 2 into 12.5, you get VA. Then write the diagram once again, enter the answer, VB equal to 281.25 kilonewton and VA equal to, both are positive, VA equal to 156.25 kilonewton. Enter the answer. Solution is over. Now, just for understanding purpose, do one thing. I will repeat once again. See, full I will repeat once again. Instead of moment about A, suppose you take moment about B. Okay, no problem. Sigma, this is, see, some will tell, he is doing unnecessary again and again. No, this is how you develop your concept. Moment about B, this point. Okay, leave it. Start. Plus VA into 8. Why plus all? If you don't understand, you are wasting your time attending my class. Minus anti-clockwise now. The total load into this distance. Total load is, already I told you, 20 plus 50, area of the trapezium, divided by 2 into distance between the parallel sides, 12.5 is the total load from full C to D, multiplied by moment. See, this total load will be acting at, I already explained, this distance. We want moment about B, so we want this distance. That is, whatever is this distance, I wrote, see how much it is from here, 50 plus twice of 20 divided by 50 plus 20 into 12.5 divided by 3 is from here to here. We want moment about B, subtract 2.5. You will first get the value of VA. Okay, I'll calculate VA now. My calculator is there. Okay. VA will come plus 156.25 kilonewton. Plus 156.25 kilonewton. Sigma V0, VA plus VB minus the total load equal to 0. Substitute for VA, you get VB equal to 281 plus 281.25 kilonewton. Okay. Solution is over. Now, make a note. Maybe some are afraid of trapezium. These formulas all we are not well versed. Okay, no problem. In that case, see here. In that case, what you do is, see, make a note here. This is your original load, C to D. See? But don't split either side. 20 here, 50 here. You write 20 kN per meter all. Then divide into parts. It will become one rectangle of, this is 20 here, this extra triangle of 50 minus 20 equal to 30. Then your sketch will become, see here, this is VA at 2 meter, VA at 2 meter. I think I can come further down. Okay, further down I can come. Okay, I got more space there. This is your VA and this is VB. Okay, distances from here to here is 2 meter. This distance is 5 meter and this distance is 2.5 meter. Okay, then see, one UDL, rectangle. This is no problem for you. See, one rectangle here. This all I explained earlier many times. Intensity is somewhere here 20 kN per meter. Over that, a triangle this way of intensity here 30 kN per meter. Now, just stagger it to show that separation. Okay, now, before you proceed further, this all I will remove now. Okay. Before you proceed further, make a note. For this rectangle, centroid will be here. See, this is a total load due to rectangle or UDL. For a triangle, total load is here, acting. So make a note. Therefore, this is equal to 20 into 12.5. This load equal to half into 12.5 into 30. Now, this is point A, This is point B. Take moment. And if you want, write anything. Say light line right here. This will be how much? 2 by 3 of 12.5, and this distance will be light line 1 by 3 of 12.5. Okay, then sigma m about A equal to 0. Take clockwise positive. Then see here, moment about A minus VB into 50. Sorry, not 50, 5 minus VB into 5 plus clockwise. See, this total load is 20 kN per meter for 12.5 meter. This is total load, that is UDL. UDL from C where? C to D, full UDL. UDL from C to D multiplied by, see, be careful, I won't write here, this will pass at center of this loaded length. If this is 12.5, light line right here if you want. See, this distance is 12.5 by 2. Even this also is 12.5 by 2. So we want moment about A into, see, this is 12.5 by 2, subtract 2. I want this distance. See, 12.5 by 2 minus 2 into 12.5 by 2 minus 2, that's all, equal to 0. Then plus uniformly varying load, half into 12.5 into, how much it is? 30 is the total load. This is the total load for UVL from C to D multiplied by, see, we want moment about A. So from A, we want this to this load. That is 2/3 of 12.5. 2/3 of 12.5 subtract 2. Subtract 2. Equal to, plus equal to 0. That 0 is not there. You will get the value of VB. Plus 281.25 kilonewton. Okay. Then sigma V equal to 0, take upward positive. Plus VA plus VB minus this total UDL. How much? 20 into 12.5. 20 into 12.5 is the total UDL right here. Again minus total for UVL. Half into 12.5 into 30 equal to 0. What you do? Substitute for whatever VB you got, you will get VA equal to, substitute 156.25 plus 156.25 kilonewton over. Answer is tallying. Okay, now do one thing. Suppose you want to make a note here. Instead of moment about A, suppose you write once again alternate solution. If you take moment about B0, see what happens then. I write change it now. If you take moment about B0, see, moment about B, plus VA into 5, be careful, plus VA into 5, minus this, see, total load is acting here. Total load here. How much it is? 20 into 12.5 is the total UDL. You write here, UDL multiplied by, we want moment about B. See, from center of this UDL, we want here. This is 12.5 by 2 from there. Subtract 2.5. 12.5 by 2 minus 2.5 is one moment. Again minus this load. Half into 12.5 into 30 is the total UVL right here into moment about B you want. This is 1/3 of 12.5. Moment about B means you want this line of action, moment from here. This distance is 1/3 of 12.5 minus 2.5 equal to 0. Instead of VB first, we will get VA first. Let me calculate. Oh, calculate is inverse. No problem. I can still see the answer. Plus 156 point, okay, red color. Okay. Plus 156.25 kilonewton. Sigma V0 will remain same, but see, same it will remain. Substitute for VA, you get VB equal to plus 281.25 kilonewton over. So, therefore, this time either you go for full trapezium, locate line of action. When you want moment about A, see the line of distance of the line of action of the load from A. From here you get it. See, from here you get it. Subtract 2 or go for rectangle triangle. Again do the same thing. Happily get the answer. Okay, now 37 over. Now I will do one thing now. I won't number the question. One question for you. Instead of this way, it is this way. You should solve it. Directly question with the brief. Okay, I will do one thing. Brief solution, 38. Okay. 38. Brief solution. See. This time I will give a sketch for you. This is the beam. See. Here maximum intensity, here lesser intensity here. This is 8 kN per meter to, I want round number of multiple of 3. 8 is 23 kN per meter to avoid fraction. But you can't expect every time that way. AB. This is the load. Now, what happens here is this distance required, this distance required, this distance required. 10 meter, my favorite number. This is 3 meter. This is 4 meter. Okay, over. Write this way. Now, start solution. Briefly I will tell, very briefly. I will dictate actually, but won't write anything. I will only dictate. Because why? Actually, now, trapezium, no problem. See here. If you, first option 1. If you are going for trapezium, as it is, see here. A is here. Your VA comes here. 10 meter, out of scale, okay. Out of scale, no problem. This VB comes here. This distance is 3 meter. This is 10 meter. This is 4 meter. Okay, little more. Okay. What is there? Little more. Okay. This one is 8 kN per meter. 4 meter. Okay. Now, if you go for entire trapezium, total load will act here. See. Distance from here will be, this is, you should write, I am not writing now, 23 kN per meter. Total load equal to 23 plus 8 divided by 2 into full length of, how much full length? 17 meter. Into 17 is the total load into this distance we want. Hurry, we want moment about A. See, AB, CD. We want moment about A. Therefore, into this distance is whatever is this distance minus 3. This distance equal to 23 plus twice of 8 divided by 23 plus 8 into 17 by 3. From that distance, subtract 3, you get the value of VB. Sigma V0, VA plus VB minus total load 23 plus 8 divided by 2 into 17, you get the value of VA. Or, if you take moment about B, here see, plus VA into 10 minus the total load remains same as last time into, see, first you decide what is this distance. This distance is 8 plus twice of 23 divided by 8 plus 23 into 17 by 3. Whatever is that distance, subtract 4, you get, subtract 4, what happens now? You will get this distance. You get VA first, sigma V0, you get VB. Okay, that is one solution. Okay, then, or, see, or, in case you are afraid of trapezium, what to do? See, now this time you construct it here. I won't explain. Already explained many times. How many times even I don't know. How many times I explained all this. Okay. So this is not red color, it is a black color. Red color is later. Okay. This is reaction VA. This is reaction VB. 10 meter. This is 3 meter, this is 10 meter, this is 4 meter. Okay. A, see this is A, this is B, this is C, this is D. If you are afraid of trapezium, what you do? You make construction. See, it is this way now. Now you get rectangle and triangle. Last time you got how? See, last time you got like this. That side maximum, here this side maximum. The rectangle will be this way rectangle. Everything you work out. If you are serious, you do it. I write here now. This intensity equal to 8 kN per meter. Over that, a triangle of this is 15 kN per meter. 15 kN per meter. How? From 23 subtract 8. This is another load. Stagger. Now, this this UDL portion resultant load will come here, center. For out of scale, okay, little that side, okay, no problem. Somewhere here, center. This is due to UDL. For uniformly varying load, resultant will come here. If you want to make a note here, this will be 1/3 of, how much total? 10, 13, 17, 1/3 of, last time I told 17 only, correct? Just earlier, when I took the distance, how much I told? I think I told 17/3 only. Okay, by chance mistake is there. Earlier for trapezium, remember, this total length is 17. Total load equal to 23 plus 8 divided by 2 into 17. By chance, I don't remember what I told. Change it. Oh, that much you can make out. Okay, now 1/3 of 17. This will be from here, will be 2/3 of 17. In that case, what will happen is, see, take moment about A. Minus VB into 10 plus UDL. 8 into 17 is the total load into, from here to here is 17/2, subtract 3 clockwise. Then half into 17 into 15 is the total load into, from A to moment about A, we want this distance, that is 1/3 of 17 minus 3, you get VB, sigma V0, VA plus VB minus 8 into 17 minus half into 17 into 15 equal to 0, you get the value of which one? VB, VA. Or if you take moment about B, work out. Take moment about B. Then plus VA into 10 minus UDL. 8 into 17 is the total load into this distance you want. From here to here is 17/2 minus 4. Same way, half into 17 into 15 is total load into this, we want this distance from here to here, 2/3 of 17 minus 4 equal to 0. You get VA first, sigma V0, same as last time, you get VB. Therefore, answer, I will give the answer now. Answer for this question, what is VA, and in the upward direction will come, and what is VB, also I will tell in kilonewton upward. Kilonewton upward. I will calculate. I will not calculate still. No problem, not a big issue calculating that one. If I do from this side, 23 plus, calculate is not on, okay. 23 plus twice of 18 divided by 23 plus 18 into 17 divided by 3 is the distance. From that one subtract 3, then multiply by 23 plus 8 divided by 2 into 17. Answer divided by 10. Why this one? I think something wrong. Because 8 and 23 is 15. Correct. Why it came odd number? No, wrong. 23 plus twice of 8 divided by 23 plus 8 into 17 divided by 3 is that distance. Something again coming odd value. 23 plus twice of 8 divided by 23 plus 8 into 17 divided by 3, some distance. Subtract 3. I got liver distance here into bracket 23 plus 8 divided by 2 into 17 equal to divided by 10. See, I don't require to write. I can see the sketch and decide. That is after not practice. It's a grip on the subject. It will come, VB will come plus 108.8 kilonewton. Then VA will come 23 plus, what is that value? 8. 23 plus, yes. You do both the solutions. 23 plus 8 divided by 2 into 17. 23 plus 8 divided by 2 into 17 is 263.5 minus 108.8. You will get 154.7 plus. No plus now, because why? I am already putting upward direction. Plus I should not write. You will get positive, therefore upwards. 154.7. I will check the answer from that side. 8 plus 23 into 2 divided by 8 plus 23 into 17 by 3 is the distance from there. Subtract 4 into bracket 23 plus 8 divided by 2 into 17. Answer divided by 10. 154.7. Perfectly correct. Okay. Solve this question. Brief solution I have given. Correctly work out and get the answer. Now I am going for once again single side overhang. I can do one question now, but no, I will do it in next class. Again, concept based question. Usually in one concept based class, only concept will be covered. So work out all this question, get ready for next class. Okay. Thank you very much.